Okay, constructing geometric sequences. So just building off what we did previously, one thing we want to do is we want to try to review a little bit of what we learned in that previous lesson. So something it's going to refer to here is the whole recursive rule thing. So just real quick, remember recursive rule looks like this. If you're using function notation, f of n equals f of n minus 1 times r. And all this is that just means previous term, okay? So really all we have to find is whatever the r is. Now the only reason I really teach recursive rule is for state test purposes. Really it has no real bearing on anything, but I do want you to see it. Let's go ahead and move forward. And again, it's always good to look at these examples, see how they work them. Might be more beneficial to you to look at that. But in this next your problem, it wants us to write both a recursive and an explicit. So we're going to talk about what an explicit rule is too. But first, let's find r. Now, if you don't remember how we found r, we said you take the second term and divide it by the first term. So r is 14 divided by 7, which is 2. In a lot of cases, what we said too, you can just look and see what's happening. So if you look and say what's happening here, you're multiplying by 2. So that's your r. Also, something else we talked about in the previous lesson. Remember, if the values are going up, r is something bigger than 1. If it's going down, then r is a fraction value that's less than 1. So here these are going up, so r is 2. So an explicit rule would be this. A recursive rule. F of n equals f of n minus 1 times 2. That's all you do. Okay, it's going to look like that every time. You're just figuring out what r is. Now, an explicit rule is going to look slightly different. Okay, so an explicit rule is an equation that you can put in a calculator. So referring back to linears, this would be doing like the slope-intercept form, y equals mx plus b. So the explicit rule for a geometric, one of them that we're going to use here is this. F of n equals f of 1 times r to the n minus 1. Okay, so what is r here? We already know r is 2. What is f of 1? F of 1 is your first term in the sequence. So remember in slope-intercept form, y equals mx plus b, m was our slope. It was our pattern, what was happening. B was called our zero term, our y-intercept. Well, in this case, we're using first term, and the reason is we use first term is because of this minus 1. Remember that. We'll refer to that again later. So the explicit rule here is, what's the first term? The first term here is 7. 7 times 2 to the n minus 1, which means I could put this, type that in the calculator. Obviously, I wouldn't use n, I would use x. Okay, let's go to the next one down here. We had a recursive and explicit rule. Okay, so what's happening here? These are going down. So that tells me my r is a fraction less than 1. So again, to get r, I do the second term divided by the first term. So I'm going to type that in on my calculator and use my simplify button. So alpha y equals 32 divided by 128. Oops, sorry. Can't operate my calculator right now. If I do that, I get 1/4. I knew that. That was dumb, Sam. I didn't have to do all that. So r is 1/4. So let's do the recursive rule. F of n equals f of n minus 1 times my r, which is 1/4. So recursive rule is easy to write. Okay, explicit rule. F of n equals my first term. What's my first term? 128 times r to the n minus 1 power. So since my r is a fraction, I'm going to put it in parentheses there. All right, so let's move forward here and let's look at another your turn problem. So down here, it says use each geometric sequence to help write a recursive rule and explicit rule for any geometric sequence. Okay, so again, it's basically the same type thing. What's happening? We are going up by 2. We're multiplying by 2. So our R here is 2. Remember, you could have done that by doing 12 divided by 6. So a recursive rule for that would be f of n equals f of n minus 1 times 2. Okay, so that's a recursive rule. An explicit rule would be f of n equals my first term. My first term was 6 times 2 to the n minus 1. Now, one thing I didn't specify that I need to clarify here, when you do this, you've got to do n is greater than or equal to 2. And the reason is because if you put 2 in here, that's going to give you the first term, and that's what you start with. Okay, 2 minus 1 would be 1, and that's what they give you here. If you put 1 there, 1 minus 1 would be 0. You don't know what the 0 term is. You just know what the first term is. So this is just to let you know that you've got to start with term number 1. And that's why you put a 2 there, because 2 minus 1 gives you 1. So just something I didn't refer to earlier, but that you'll need to know for your online homework. Okay, so let's move on. We're going to go 2 pages over. Again, you can always look at the example here to help you if you need to. But we're going to do this last year term problem here. So it says, write an explicit rule for the sequence using subscript notation. So this is just a different notation. So where we've been using explicit rule, f of n equals f of 1 times r to the n minus 1. It's going to look a little different, but it's the same concept. Okay, so now what we have is we have the third term. Okay, so we don't know term 1. We don't know term 2. We know term 3 is 27. We don't know term 4. We know term 5 is 243. 1 over 243. It says all the terms are positive. Okay, so the first thing we have to do is we got to figure out what R is. So how in the world do we find R? Okay, so to do that, there's some differing ways to do this, but the easiest thing to do first is recognize what kind of R do you have. Well, that value, even though it skipped 1, it went down. So that means R is a fraction less than 1 again. Okay, so make sure you get that concept because it is going down. I'm going to do some erasing here so I got some room to write. All right, so let's go from there. So how can I find R? Well, again, there's some multiple ways to think about it, but what I'm going to do is I'm going to use that explicit formula. Now, I'm not going to do it in subscript notation yet because I don't want to confuse you. So what I'm going to do is I'm going to take this. I know term number 5. Term number 5 is 1 over 243. Okay. I don't know the first term. Okay. So at some point, I got to find term number 1. But what I do know is term number 3. Now, how would I get term 3? Well, I would get term 3 by doing R 2 different times, okay? In other words, if I go backwards and do the reverse of R. So the same is true. If I want to go forward to get the 5th term, I have to do R twice. So I would multiply by R and multiply by R. Okay, so what's that look like? So to get term number 5, I take term number 3, which is 1/27, and I have to multiply that by R twice. Okay, so what's it mean when you multiply something by itself? That means it's squared, okay? So really I get 1 over 243 is 1 over 27 times R squared, okay? Now let's think about solving for a variable. First thing I'm going to do is divide by 1 over 27, or, okay, what I prefer instead of doing division here is think of it as multiplying by the reciprocal. 27, oops, that's a 7 there, 27 over 1. Okay, so when we do that, so if I simplify that there, that's going to give me another fraction. So I do 27 over 143, or 243, sorry, 243. If I do that, I get 1/9 equals r squared. Now, later on we're going to learn this too, but how do you get rid of a square? You take the square root. What's the square root of 1? 1. What's the square root of 9? 3. So my r is 1/3. Okay, my r is 1/3. So what that means is, think about it now this way. If I'm going to do this pattern, if I multiply by 1/3 here, so I do, let's see, multiply that, that's going to give me 1 over 81. Well, if I multiply that by 1/3, guess what I get? That. So that tells me my r is right. Now, to write an explicit rule, I've got to find term number 1 here. So what am I going to do? I'm going to go backwards. So I'm not going to multiply by 1/3. Instead, I'm going to do the reciprocal, which is 3, multiply by 3. If I take 1/27 and multiply by 3, I get 1/9. If I take 1/9 and multiply by 3, then I get 1/3. So term 1 is 1/3. So if I wrote it in this notation, it would look like this. F of n equals 1/3 times 1/3 to the n minus 1 power. Okay, subscript notation just looks like this. Instead of using function, subscript looks like a to the n equals a to the 1, where that's first term, times r to the n minus 1. That's what subscript notation looks like. So it would still look like this. 1/3 times 1/3 to the n minus 1. And that's subscript notation. So just a different way of writing it. A little more challenging problem in terms of trying to find your first term and your r, but hopefully you get it in relationship to what we did with linears. Just make sure you understand this whole squaring and square root thing. So